All right. So we're finishing 9.4 today, and it should go pretty nicely. Really, 9.4 is the calm before, well, the calm before and the calm after the storm. Okay, so I'm hoping that people have an easier time with this section. Both of these sections, 9.3 and 9.4, are due on Wednesday and will be covered on your quiz, which I will be giving more time on the quiz this week. Okay. And with 9.4, we are going to be finishing our identity sheet, which you should have. And if you don't have one of these, you can still print it off of Canvas. All right, it's under the important documents module. So 9.1, we talked about a lot of the huge ones. 9.2, we talked about sum and difference. 9.3 was pretty tricky. We used the sum and difference identities to get double angle formulas, power reducing formulas, which can also be used as half angles. So I'm expecting 9.3 to be the big challenge so far. And then 9.4, we're doing these ones. These are usually easier to use. And then 9.5 is when we kind of throw everything we've learned in this class all together. We're starting 9.5 on Wednesday. It's going to be hard. We may spend 3 full days on 9.5. Okay. 9.5 is a tricky section. But I believe in all of you. You can do it. So let's do 9.4. Should be a quick day today. We don't have that many problems to do. A lot of this section is pretty straightforward. Okay, so what the plan is just do the examples. You ask questions as you have them. And if there are not a lot of questions, there are some homework questions that I got asked to cover. So we'll be going some of the homework problems from 9.3 afterwards, which should be very useful because 9.3 is tricky. Okay. If you missed chapter 7, don't worry. Chapter 7's coming back when we get to 9.5. Starting on Wednesday, it gets very chapter 7-y again, as well as some other stuff. So it's coming. It's coming. Okay, let's go. I should probably change my scene. Here we go. So we are going to cover 9.4b today. And specifically, this is going to be the product to sum part. So let's go example 2. Write as a sum. And again, for context, right? For context, these problems, we're not solving anything. We're not simplifying anything. We're just moving things from this form to that form, okay? So we're just kind of moving things around, getting practice with it. Later on, we're going to be using all this stuff. This whole chapter is heavily used in calculus, and then there are some other uses as well for solving like equations and stuff, which we'll be doing in the next section, solving equations. And solving equations is essentially one of the most important things you can do in mathematics because we use equations. And I mean mathematicians, not necessarily in this class. We're not going to be doing that many applications. But one of the main uses of math is to model real life situations with equations. So if we can't solve the equations, what good's the model, right? So that's kind of the driving force behind what we're doing here. That was a very weird motion I made. So let's get into this. Part A, 2 cosine of 7x over 2 times the cosine of 3x over 2. Okay? Again, if this were, we're just gonna write this as a sum instead of a product. So we have a product, we need a sum. So we're gonna consult our product to sum formulas. Which one of these do we use? Well, we just look at what we have. We have a cosine times another cosine. So, this one. It's a cosine times another cosine. We'll use the second one right here. And again, one of the best things that you can do when you're trying to use an identity is write it down on the side. So that's what I'm going to do over here. Okay, we're using the cosine u times cosine v. Oh, that's not quite right. Cosine of u times the cosine of v is going to be equal to 1/2 times the cosine of u minus v plus the cosine of u plus v. Okay, that's the formula. And that's what we're using here. But notice we have something a little different, right? So this right here is our first angle. We'll call that u. This right here is our second angle. We'll call that v. We got a 2 sitting out in front. And that's okay. We could modify this formula to put a 2 out in front if we wanted, right? Or one thing that you could do, right, if you really wanted to, you could write this as 2 times cosine of u, which is 7x over 2, times the cosine of v, which is 3x over 2. Right, so this 2 is not a problem. We're just going to use the formula on this part. All right. And the 2 is just going to sit out in front. So if you have a number out in front, or even if we had another sine or another cosine or I don't know, a pink flamingo, whatever, it doesn't matter what we have out in front. We just replace the cosine with the identity, right? Just like, you know, if you're solving, oh, this is really going off on a small tangent, but it's relevant. Just like if you're evaluating something, right? If I say evaluate this when x is 5, you just replace all the x's with 5s. Similarly, this is identity. We're just replacing the cosine with what it is. Okay? Yeah, so all of the videos here are being posted to Canvas afterwards. So it's best if you watch them live. But if you want to watch them again, you can watch them on Canvas. So yes, exactly, Brock. The 2 on the outside is going to end up canceling with the 1/2 on the inside when we plug it in. So I'm going to be doing this in steps because I really don't want to skip things, because it's tempting to skip things when I teach online. But yes, you could really just cancel them out immediately. So I'm going to replace the inside. Cosine of u times the cosine of v is going to be right here. 1/2 times the cosine of u minus v. What's u minus v? 7x over 2 minus 3x over 2. Plus the cosine of u plus v. u plus v. 7x over 2 plus 3x over 2. And yeah, exactly. This 2 times the 1/2 is going to cancel out. Oops, I am missing parentheses here. This looks kind of messy. But 2, 1/2, they definitely cancel. And all we're left with is the cosine of the difference plus the cosine of the sum. And we just simplify and we're done. Okay, so we get cosine of, they have the same denominator, so we just subtract the numerators. 7x minus 3x is 4x. 4x over 2 plus the cosine of their sum. 7x plus 3x is 10x. And now we just reduce, right? 4x divided by 2 is just 2x. 10x divided by 2 is just 5x. And that is our answer. It is just an equivalent form of where we started. But now it's written as a sum. And sums have some advantage. And products have other advantages. So we're just using this section to be able to switch from one form to another. Right? And that's really the section. If you've got this, you can pretty much ace this section. And this will be half of what's due on Wednesday for the quiz. Okay? Let's do some more of these. Really just make sure that we're good here. Part B. The plan is to do part B together, and I'm going to give you a minute or two to attempt part C. All right? Part B. Ooh, I had an orange for breakfast, and now my hand smells like an orange. I like the smell. Part B is sine of 4 theta times the cosine of 2 theta. So we really just solve this problem the same way we did it. We need to find the formula for this. We need to find the identity for sine of u cosine of v. So we consult our identity sheet. Sine of an angle, cosine of an angle. That's this third one right here. Sine u cosine v. So we just copy that down. Going to be 1/2 times the sine of u plus v plus the sine of u minus v. I did not give myself a lot of room to write this. And then again, u is just this first angle, and v is just the second angle. So we get that 1/2 sine. We can go a little faster on the second example. It should be the sine of u plus v. What's 4 theta plus 2 theta? 6 theta. All right, plus the sine of u minus v. U minus v is 4 theta minus 2 theta, which is 2 theta. So if you want to go fast like this, you can. And this is a good final answer. If you wanted to distribute the 1/2, you could as well. Okay. So if you wanted to write it as 1/2 sine 6 theta plus 1/2 sine 2 theta, that's A-okay with me. Right? And this really is the section. Okay, so go get it. Make sure, ideally, right, when you're watching these videos, you are taking notes along, just like if it were a face-to-face class. And if you ever need me to slow down for you to catch up, just tell me to slow down. This is now for part C. Do it on your own, okay? So start part C. I'll give you a minute or so, and I'll show the identities if you don't have the identity sheet with you. Do the same thing for the cosine of 3 theta times the cosine of 5 theta. Okay? And real quick, I will get the identity sheet visible for you. There we go. Take about a minute. Feel free to keep working. I'm going to start going through things. So I hope you at least got to this point that I'm writing down right now. But there's one more step to do here. Yes, exactly, Bob. We're going to use that parity identity, the fact that cosine's an even function. So even though in the previous examples we actually stopped right here, we can go one step further. Because the negative over here is essentially redundant. It's essentially more math that we just don't need to do, right? Parity identities right here, even and odd functions. Cosine's an even function, so it doesn't matter if you plug in a negative, it's going to be the same as if you plugged in the positive. All right? The negative goes away in essence. So we can actually take this one step further. Get 1/2 times the cosine of positive 2 theta plus the cosine of 8 theta. Okay. And this is actually kind of cool how it works out, by the way. So, right, multiplication is commutative, we say, which means that we could write this multiplication in either order. If we wanted to write the 5 theta first and the 3 theta second, we could do that. And then this would become 5 theta minus 3 theta, and this would be 5 theta plus 3 theta. And then there wouldn't be a negative at all. So if we switch the orders of these, we wouldn't have had to use a parity identity. So it's kind of cool that you can see, regardless of which order you write it in, you still get to the same answer, even though it might look a little different if you do. Good. All right, and that's the chunk of the section. Any questions on this before we just do some verification problems to finish us off? All right. Then let's go. Let's do some verification. Verify. Cosine of 4t minus the cosine of 2t divided by the sine of 4t plus the sine of 2t equals negative tangent of t. So this looks awful, right? This looks super messy and super bad. But if you remember how your identities work, and you remember algebra skills, it's actually not bad at all. This actually becomes pretty nice, this problem. Because look at what we have here. So first off, I want to tell you how to recognize what to do for this problem. So we could split up the numerator, but we cannot split up the denominator. You can never split up denominators and fractions when there's addition. Okay, and either way, we don't want to split things up because something has to happen. Because notice that we have 4t's and 2t's on the insides here, but we want them to just be a single t. So there's really only a couple ways of doing that. We could use double angle formulas, and I'm pretty sure, not positive, but I'm pretty sure you could use double angle formulas on this problem. It would be very time consuming though. I think it'd be really messy. But obviously, since we're in the sum to product and product sum section, that does seem to be more likely using that formula. All right. Another reason why we want to use sum to product here is because if we remember how I said we can't split up the denominator because we have addition here, we can also not cancel anything because we have addition here. So fractions in general are way nicer to work with if we write them as products. That's why, right? Again, going off to the side somewhere. I don't really have room here. Going off to the side, right? That's why, remember back to like your algebra days, if you were solving or trying to simplify something like this, what's the first thing that we did to simplify something like this? We factored it because this is a bunch of addition. Addition's no good. But if we factor things, now it's multiplication, and multiplication is so much nicer to work with in fractions. So this is one example where using the sum to product form is a good idea because we have fractions, and products are way nicer with fractions. And of course, in this situation, we would then start canceling and simplify. So that's kind of what we want to hope happens here. If we have products up here, that would be really nice. So this is going to be a little bit messy. We got to use a lot of formulas, and that's okay. We got to use a formula on the top. We got to use a formula on the bottom, and then pray that our algebra skills are going to not lead us astray. So for the top, let's go off to the side. First off, we are starting with the left-hand side. There's way more that we can do with the left-hand side than we can do with the right-hand side. Pick a side. Technically, it doesn't matter which side you pick, but sometimes picking a side will make the problem a little easier. So let's start with the numerator. We need to use a sum to product form for cosine and cosine. Cosine minus cosine. What is that formula? So let's go off to the side and say what situation do we have? We have cosine of u minus the cosine of v. Let's find that in our formula sheet. Cosine minus cosine, that's going to be this last one. Yeah. All right, it's going to be this last one. So we just copy that down. All right, it's going to be negative 2 sine of their average, u plus v over 2, divided by, or times sine of their difference divided by 2, u minus v over 2. All right. I'm not dying. I'm not sick. I just sneeze every once in a while. All right. So then again, u for the top is 4t. V for the top is 2t. So the top becomes negative 2 times the sine of u plus v divided by 2. Just replace the u's with 4t's and the v's with 2t's. It becomes 4t plus v, which is 2t, over 2 times the sine of their difference divided by 2. 4t minus 2t over 2. And again, you might start sweating right now. You might start sweating and say, this looks terrible. Look at what we got here. We got multiple signs in the top. We got fractions on the inside and variables everywhere, but don't worry, just have patience. So many of these verification problems, if you just have a little patience, have a little faith, and a lot of algebra, will all work out. Okay, and we do it in the bottom too. But the bottom is a different formula, right? Bottom is sine plus sine. So we also need sine of u plus sine of v. Same u and v. So we consult our identity sheet. Sine plus sine. That's the first one. So that's going to be 2 times the sine of their average times the cosine of their difference divided by 2. So we just plug that into the bottom. 2 times the sine of their average. Wait a minute. Sine of u plus v over 2, that's sine of 4t plus 2t divided by 2. That looks a little familiar. Look, they're stacked right on top of each other. Just like this situation over here. Once we write things as products, beautiful things are going to start happening. And there's a cosine of their difference, 4t minus 2t divided by 2. And again, this is a big boy, but a nice big boy, okay? So now that everything's written as a product, it's just like this algebra problem. We can cancel and simplify. So look, we have got it, again, you can only simplify once everything's multiplied. But we do have everything multiplied because we use the sum to product formula, right? So we got a 2 on the top and a 2 on the bottom. Those cancel completely. I don't even need to simplify this inside, right? We've got sine of something divided by the sine of that same thing. I know that cancels too. You could simplify it first if you wanted to, but they're gonna simplify the same way. They're the same thing, so they cancel. And exactly, sine divided by cosine's tangent, so this last one just turns into the tangent. All right, so what are we left with? We're left with a negative sine times the sine of this divided by the cosine of this. That's going to be the tangent of it. And if you want to write 4t minus 2t divided by 2 again, you could. But let's just simplify it a little bit. 4t minus 2t. It's just 2t. And, cosine over sine is cotangent. So we get this. And what happens is 2t divided by 2 is just t. Perfect. All right. That's one way to approach verification problems like this. And again, one really kind of nice use of the sum to product formula is being able to cancel things in fractions. Good. Any other questions on this one before we do the last problem of the day? My cat is currently trying to climb up my jeans. I'm not sure how I feel about that. Hey, October, don't do that. Cotangent is a wannabe tangent. Yeah. Preach it. All right. Last problem, and we're going to do some review that you can enjoy or not enjoy, as you prefer. Okay, let's do part B. Now, part B is a sly one, okay? Oh. Right now, she's like clawing at my notes on the ground. Oh, my word. Anyway, it's distracting me, but it doesn't need to distract you. Cosine squared of theta minus 2 equals the cosine of 2 theta divided by the sine squared of theta. Now, this one's a sly one. Hey, don't eat that. Don't. There's no eating of mathematics here. So this one's a sly one because try to figure out what to do. In the meantime, I'm going to move this thing. Be right back. All right. So we have to decide which side we want to start with. Both sides, I think, are pretty good choices here. If I started with the left-hand side, I would write cosecant as 1 divided by sine, and then combine the fractions. Because we want to combine fractions, because over here, we only have one thing, and over here we have two things. Over here we only have one thing, so we would have to combine the fractions so it becomes one thing. Or I could start on the right-hand side and use a double angle formula for sine. I'm going to show you guys both ways. Okay? In this one, really, you do have a choice. If we start with the left-hand side, right? Cosecant squared is 1 divided by sine squared. And this can be a good idea to write it like this because we want a sine squared in the denominator. So again, right, we really need to be able to combine these two things. There's no subtraction over here. There's only one fraction on the right-hand side, and always we want to be looking at where we're going. So to combine these, we need a common denominator. That common denominator is going to be sine squared, so we multiply this by sine squared over sine squared. And what that gives us is 1 minus 2 sine squared of theta divided by sine squared of theta. So this looks better. Now, we have one fraction, and our denominator is exactly what we want the denominator to be. We want to show that the left-hand side is equal to the right-hand side. If only that numerator were equal to the cosine of 2 theta, then we'd be done. Only that numerator were equal to the cosine of 2 theta. Well, cosine of 2 theta is cosine squared minus sine squared. No, we don't have that. 2 cosine squared minus 1, we don't have. Oh my gosh, it is, Brock says. Yes, what a coincidence, what a surprise. Who could have seen this coming? It's just an identity. This is exactly what we have. 1 minus 2 sine squared. And that's just cosine of 2u. Okay, so we get cosine of 2 theta divided by sine squared of theta. Wow. Exactly what we wanted to show. Okay. And I was actually going to show the other way, but really if you go the other way, it's literally just the reverse. Okay. If you started with the right-hand side, you would say, okay, we need to use a double angle formula for cosine. And you could use any of them. This one is the easiest. And then you just split up the fraction to get 1 divided by sine squared, and the other flat fraction cancels, and you just have the 2. So it doesn't really seem useful to show the other way since we really kind of did both ways at once. All right, and that's the whole section. Okay? That is the whole section. So for the extra credit for attendance points for today, send me the name of a state in the United States. That's the answer. What's the circumference of the sun? A big number. Oh no. To get your extra credit points for today, yeah, send me the name of a state on Discord. Any state, doesn't have to be Wyoming, although it could be. Doesn't have to be your favorite state, just a state. And so what we're going to do for the rest of class, if you are confident on 9.3 and you say, this was 9.4 by the way. If you're confident on 9.3 and you say, I don't need to stay for more problems, go ahead. You can leave, it's fine. But if you want to do some 9.3 problems, I'm going to be talking about them because a student sent me a list of questions about a couple problems on 9.3. So I figured we could just go through them since we'll have extra time today. All right. Wyoming isn't real. Maybe. So let's start going through these real quick. I do have to tab a little bit, make sure that I'm answering them. All right, so let's go over some 9.3 problems, shall we? Oops, I tabbed over and then I want to untab. So we're gonna find 9.3. This is the second artist section probably. Okay, so for these ones, This is going to be similar to what we did on the quiz before, where you're told information about 2 theta and information about theta. I want you to find the 6 trig function values of theta. Okay, so 9, I'm probably not going to do all of these, but I'll do part of them. Okay, so for example, on number 9, right, we have that cosine of 2 theta is 3/5, and we know that theta is in the 3rd quadrant. It says it's between 90 and 180 degrees, but that's 3rd quadrant. So we draw a picture. Wait, it tells us where theta is, not 2 theta? That's kind of strange. Usually it would tell us where 2 theta is. Wait a minute. Well, so 2 theta has got to be between 180 degrees and 360 degrees. Wait, theta, wait, 90 to 180, that's in the 2nd quadrant. So theta is in the 2nd quadrant. So we know 2 theta is either in the 3rd or the 4th quadrant. But I guess it doesn't really matter whether it's in the 3rd or the 4th. We know 2 theta has to be in the 4th quadrant, right? Because cosine's positive. Okay. So that's right there, kind of a hard way to start, right? So what do we know about 2 theta? So theta, right? Theta is between 180 degrees and 90 degrees. So to find out information about 2 theta, we just double everything, right? So 2 theta is between 180 and 360 degrees. But we also know, right, so this right here means 3rd or 4th quadrant. We also know that cosine of 2 theta is positive. So that means, well, that narrows it down, right? 3rd or 4th quadrant. But if cosine's positive, it has to be the 4th quadrant. Okay, so 2 theta is in quadrant 4. I really don't even think you need to know where 2 theta is, but I like to know where it is so I can draw a triangle for 2 theta. All right, if this is an angle 2 theta, some angle called 2 theta, you don't have to, it's kind of weird to have the 2 there. You could call it phi or v or u or a or alpha or beta. You could call it whatever you want. But if this is in the 4th quadrant and the cosine is 3/5, it could look something like this, where the adjacent is 3 and the hypotenuse is 5. We could use Pythagorean theorem and special triangles to get that this is -4. Negative because it's going down. But again, this is not important. We're asked to find 6 trig function values of theta. All right. So what is cosine of theta? Well, why would we just start with cosine? Let's start with sine. Right? To start with sine of theta, we need to use a half angle formula. Okay. So we consult our identity sheet. An identity sheet says half angle formula is up here. And remember, you may have written an alternate version of this by taking the square root of both sides. Okay? So if you do that, you get that the sine of theta is going to be the square root with a plus or minus in front of it, 1 minus cosine of 2 theta over 2. Oh yeah, we didn't actually need to find this stuff. This was optional. A little for fun information. Because we're using the half angle formulas, and all the half angle formulas only use cosine anyway. Okay. But, you know, a little extra information, a little extra problem solving for you. And now we can get a pretty picture that we didn't need. So remember, this plus or minus in the half angle formula doesn't mean we have 2 answers. It means we have to choose whether we're plus or minus. And the way that we choose here is we know that theta is in the 2nd quadrant, right? Sine's positive in the second quadrant. So if theta is in the second quadrant, the sine of theta will be positive there. So we know that we're going to need the plus side for this formula. So the sine of theta is the positive square root of 1 minus what was cosine of 2 theta was 3/5 divided by 2. And now you just simplify. Okay. Why is it positive? Because theta is in the second quadrant. Okay. We were given this information in the problem. And in the second quadrant, sine is positive, cosine and tangent are negative. So for cosine and tangent, we choose the negative part, but not the positive part. So let's simplify this. We have a complex fraction. We need to eliminate the complex fraction, so let's multiply by the LCD, 5 divided by 5, and distribute. Okay? So on the top, it distributes to become 5 minus, and on this one, the fractions cancel. We get 3. On the bottom, we get 5 times 2 is 10. And we just simplify. 5 minus 3 is 2 over 10, reduces to 1 over 5. Oops. Going a little low here. And I will accept, well, this simplifies a little bit, right? Square root of 1 is just 1, so we have 1 over root 5. I will accept this. If you want to rationalize the denominator, you could also multiply by root 5 over root 5 to get root 5 divided by the square root of 25, which is just 5. I'll accept either one of these answers. All right. So that's how you do these problems. You didn't need this thing circled. All you need is the half angle formula and utilize it. And you just, for the other ones, because, right, you'll need all six trig function values. For cosine and tangent, you just do the same thing, but with the cosine and tangent formula. And remember, those are going to be negative in the second quadrant. And then also, right, cosecant is super easy now because we already found sine. So cosecant is 1 over sine of theta. So it's just going to be the reciprocal of this, which is root 5. So we just found 2 of the 6 trig function values. Okay. And that's basically it. So that's kind of how you do that first chunk of problems. Hopefully that answered the question. The next question was on number 21, how to know what formula to use. So you're trying to find the exact values of the half angles without actually solving for x. So you do this the same way that you did the previous problem. Okay. So for 21, we're going to do something very, very similar. All right. Here's what we have for 21, right? We need to find sine, cosine, and tangent. Let's find cosine, do something a little different, okay? So let's find the cosine of the half angle, x over 2. Where x is between 0 and 360. So now it's not telling us what quadrant x is in. All right. So what we have right here is we know that sine of x is negative 12/13. Oh, it does tell us the quadrant here, right? X is in quadrant 3. All right. So we're going to draw a picture. Actually, again, we don't need to draw the picture. If x is in quadrant 3, though, we need to find out what quadrant x over 2 is. All right. So x is in quadrant 3. What range? So let me write this down, right? Need to find the quadrant of x over 2. So x is in the third quadrant, right? So what does that mean? Right? If you're in the third quadrant, that means we're more than 180 degrees, but less than 270. The question is, what is x over 2? We just divide everything by 2. Right? If we divide everything by 2, we get 90 degrees is less than or equal to x over 2, which is less than or equal to 135 degrees. What quadrant is this, right? More than 90 degrees, but less than 135, we know we're in the second quadrant. So we're going to use this information to use the half angle formula for cosine. So we know what sine is. We need to find the half angle for cosine. All right, so pull up our identity sheet. What's the half angle formula for cosine? You find it right here if you just take the square root of both sides. All right, so the cosine, so it's written as cosine of u and cosine of 2u, right? Let's let u, here, I'll write it. Let's do one thing at a time. Cosine of u is plus or minus 1 plus cosine of 2u over 2. And let's let u be the thing that we want to find, right? What do we want to find is x over 2. So we know that the cosine of, if u is x over 2, just replace it. Is plus or minus, and again, we look at the quadrant for 2, or for x over 2. What quadrant is this in? It's in the second quadrant. Is cosine positive or negative in the second quadrant? We know we're in the second quadrant. Cosine's negative in the second quadrant. So use the negative sign. Square root of 1 plus cosine of 2 times u. Right? If u is x over 2, then 2u, the 2's cancel, is just x. And now we need the thing that I thought we needed in the last problem, right? We're only given what sine of x is. We need to find out what cosine of x is. All right? So to find out what cosine of x is, right, we know sine of x, but we need cosine of x. So we need to draw a triangle. So x is in the third quadrant. That was given to us. Right, so if this is x, we know that sine is negative 12 over 13, opposite over hypotenuse. We can use the Pythagorean theorem to get that this is a negative 5. Negative because it's going to the left. Left or down means negative. Okay. So the cosine of x, right, is just the adjacent, negative 5, divided by the hypotenuse, 13. So we can use this and plug this in over there. So we get the negative square root of 1 plus a negative number is going to be 1 minus 5/13 over 2. And now again, we just simplify. We have a complex fraction. That means fractions inside of fractions. So we want to undo those. So we're going to multiply by 13 over 13 on the inside of the square root, and we distribute just like we did in the previous one. The first one, we get a 13. Second one, the 13's cancel. We're just left with 5. Denominator becomes 26. And now we just get negative. This becomes 13 minus 5 is 8. Over 26, reduce, become 4/13. Square root of 4 is 2. So we get negative 2 divided by the square root of 13. And again, I will accept this answer. But if you want to rationalize the denominator, it's sometimes a good idea. Multiply by the square root of 13 over the square root of 13. You get the square root of 13 squared on the bottom, which is just 13. I'll accept either of these answers. And again, this is just for cosine. You can also do it for sine and tangent. Okay. Let's look at the other questions. We got about 6 minutes left. Should be able to do this just fine. 26 and 27, what's the difference between these two? They're actually very similar. Actually, this is a great question. I like this question. So in 26, you're trying to find all the half angles for theta. And on 27, you're trying to find all the half angles of alpha. And there's an interesting relationship between those two. But it's actually not as simple as I immediately thought. Alpha and theta are complementary. Alpha and theta are complementary. So their cofunctions are equal, but the cofunctions of their half angles are not equal. So it's just a slightly different situation. Just use the formulas here. And since we're dealing with triangles, not coordinate planes, you don't have to worry about negatives or positives. Everything will just be positive for 26 and 27. So next question was the proofs. Yeah, you just choose a side and use an identity. And you don't know what formula to use. You just have to simplify and see what goes on. So for 34, for example, you could start with either side. And if you started with the left-hand side, you would start with algebra. You'd FOIL out the left-hand side to see what happens. And then if you ever get stuck, you just scour the whole identity sheet until you find something that you can use. If you start with the right-hand side, I think it's a little easier to see what identity you're going to use because the right-hand side has a double angle. So if you start with the right-hand side, you're going to want to use the double angle formula. I actually think starting with the left-hand side is easier for 34 though. And again, with 35, you could start with either side. Right-hand side's a little easier on 35, but you could start with either one. If you start with the left, you'd start with the double angle formula. If you start with the right, you'd start with the parity identities, okay? So the fact that sine is an odd function means this negative comes out and they cancel. The fact that cosine's an even function means the negative goes away. And if you start with the right-hand side after one step, you have 2 sine of x cosine of x, which is just the double angle. And these ones you do like, we did some of these in class. So look at the video. I think it was somewhere in the middle of class. We just used the power reduction formulas. Okay, I'll do one of these. Oh no, we just finished a piece of paper. All right, I'm going to be using an extra piece of paper. Goodbye, environment. I'll show you how to do 30. I'll show you how to do 38 since 30. Actually, let's do a harder one. I'll show you 40. Okay. So for 40, we have sine to the 4th of 8x. And we want to write this with an exponent no bigger than 1. So to do that, we're using the reduction formulas. Okay. These ones. We have sine to the 4th, though. And the reduction formulas are only for sine squared. But remember, we can write sine to the 4th as sine squared, no problem, right? Sine to the 4th is just sine squared of 8x squared, is it not? Right? Just like, if I gave you something like a to the 4th, that's a squared. And now we have a sine squared that we can reductionize. All right. So now we use the reduction formula on this one. So we go off to the side. We copy down our reduction formula. Again, the reduction formula is right over here. Power reducing. We need to reduce sine squared. So we're going to copy this down on the side. Sine squared of an angle is 1 minus cosine of double that angle divided by 2. What's our angle here? It's 8x. So this is our u right here. So we just use this formula. And again, we're only using the formula on the inside. We're replacing the sine squared with this right-hand side. This bracket, the things outside the bracket are still there. So we're just putting the formula inside here. Okay. So the formula says it's going to be 1 minus cosine of double the angle. What's double this angle? 16x divided by 2. And this is why I chose to do number 40 instead of one of the easier problems, is because we're not done yet. This whole thing is being squared, so we need to simplify this. All right, so we have the top squared, so 1 minus cosine of 16x squared, and the bottom squared, well, 2 squared is just 4. So we need to FOIL out the top, right? So I'm going to go off to the side just to save a little bit of room. All right, 1 minus 16x squared is 1 minus cosine of 16x times 1 minus cosine of 16x You could FOIL that out. First, outer, inner, last. But we're going to use a shortcut. By now, you're probably familiar with the fork cut. The shortcut for simplifying perfect squares of binomials. It's the first thing squared. So 1 times 1 minus their product times 2. So minus 2 cosine of 16x plus the last thing squared. So plus cosine squared of 16x. And the denominator is a 2 squared, which is just a 4. And lo and behold, you get to do it again. Oh, dang it. When I did this problem in lecture, when I did a problem similar to this in lecture, I said, there's an easier way to do it. Write it as sine squared times sine squared instead of doing it like this. And now I thought I got them flipped up. So I was like, oh, when I answer number 40, I'm going to do it the easier way instead of the harder way. And I just did it the same way I did it the last time. But it's okay. This way works too. So now we need to use it again. And for time's sake, I'm not going to do it again. But you could. All right. Because we're asked to write it with no powers greater than 1. And we have a cosine squared here. We need to use the power reducing formula again. All right. Real quick though, I'm going to do it. Let's do it speed. I'm going to go through it super fast the other way. We could write this sine squared 8x, sine squared 8x. Use the formula on both of them. So 1 minus cosine of 16x over 2 times 1 minus cosine 16x over 2. And we multiply those together. And we get, well, this really just going to get to the exact same spot, right? Multiply both of those together. We are going to get 1 minus 2 cosine of 16x plus cosine squared of 16x. The denominators multiply to become a 4. Which is exactly where we are before. I'm going to finish this, but I'm going to go really fast. It's a lot easier to factor out the 1/4, so we don't have more ugly fractions. And then we're going to use the reduction formula on this cosine in the inside. So we're going to use the reduction formula on that to get 1/2 1 minus 2 cosine of 16x. The reduction formula is going to give us 1 plus cosine of double the angle, which is 32x over 2. And that's the final answer. And you just simplify. Okay. But not simplify this specifically. Simplify the whole thing. And you'll be done. Kind of long problems. All right, so hopefully that answered all of those questions that were emailed. Please continue asking questions. A lot of people think that you should not ask questions or they feel uncomfortable asking questions. But really, what is the most important thing to you as a student in this class? I hope one of the most important things is that you succeed. I hope that's important to you. Okay? And one of the best ways to succeed is to ask questions. There are some downsides to asking questions. You may feel embarrassed. You may feel uncomfortable, but just weigh it, right? What's more important, success or comfort? So thank you for asking the questions to whoever asked this, and feel free to ask some more. Okay? So to rationalize the denominator just means to get a rational number out of the denominator. So right over here, we have the square root of 13. This is not a rational number. It's an irrational number, which means that if we wrote this as a decimal, it would go on infinitely without any sort of pattern, just like pi and e, Euler's number. So to rationalize something like that, we multiply it to get the denominator to become a perfect square. Because, right, the denominator is now the square root of 169, which is 13. Now the denominator is a rational number. There are some advantages to doing that, but it's not usually that important to me and a lot of other mathematicians. Anyway, that's it for today. Good luck. Let me know if you have questions. Bye.